Hi, now that we know a little bit about software testing, we then discuss some principles. And this is a lot of this discussion was based on the question, uh, what is enough testing for us, right? So when should we stop testing because we are sure that our software doesn't have bugs? Can we answer this question? And the first principle we discussed is the one from Dijkstra, and he says that testing shows the presence of defects, but testing never shows the absence of defects. So in a way, if we're doing tests, the test tells us that the bugs we're trying to find are not there, but there might be bugs that we are not testing for that might still be there, and this is some sort of this is tricky, right? And this is in a way related to the fact that exhaustive testing is impossible. If you want to test all the possible inputs, all the possible combinations, and etc., the number of combinations is just too high. We cannot do it. We don't have money for that. We don't have machines for that. We don't have people for that. So testing everything is impossible. And what we try to do is to then find, prioritize what to test. And another funny thing about tests is that bugs are not uniformly distributed in our software, right? So, for example, one may expect that if you have 5 modules in your software, 20% of the bugs will be on module 1, 20% of the bugs will be on module 2, 20% of the bugs on 3, and so on and so forth. But that's not actually true. We see that distribution is not uniform. So this means maybe for some components you're going to have to put more effort, but for some other components you're going to put less effort because they simply have less bugs. And another tricky thing is that what we notice is if you're always using the same methods to find bugs, to write tests, for example, you're only doing structural based testing, you're going to end up with what we call the pesticide paradox because at some point those methods won't be efficient anymore. And this is like a pesticide, right? If you're always using the same pesticide, at some point it's going to stop working, right? Um, we need variation in testing. That's the conclusion. So we need to always have different approaches and try different approaches to find bugs. Variation is a fundamental thing in testing, right? So we need to think about all the things we can vary, and it can be the input, it can be the state of the system, it can be the environment, for example, Windows or Mac. There might be bugs in there. So varying things is an important software testing task. Testing is very context dependent. This means if you're testing a web application, maybe your techniques will be different than if you're developing a mobile application. So the context matters, and maybe the effort you're going to put in a software that calculates tax money is different from a software that just calculates, I don't know, nutrition facts of food, right? So the context matters a lot on how to design your testing activities. Having no bugs is not enough. This is related to verification versus validation. Uh, if you don't have bugs, this doesn't mean your software is useful, right? Maybe your software doesn't do what the customer wants it to do, and then at the end of the day, there are no bugs, but the software is not useful. So this is why validation is also important. So that was it, the principles.